All right, so we're going to do a little tutorial on natural log and E and how those work and how really they're just very, very similar to logarithms because it's a specific type of logarithm. So I want to call your attention a brief overview of day one of logs. If you have log base b of x equals y, to put that into exponential form, x equals b to the y. That is not new. This video is not for that purpose. There already is one about that. But we're going to use this knowledge to help us with this transition with natural log. Now, what a natural log is really just a logarithm with a base of e. Now, you'll never see log base e. It'll always be represented by natural log. But doesn't this transition make sense now? Because if we were to follow the logarithm road to actually get to exponential, that's all they're doing here. So when you have natural log of x equals y, that is the exact same thing of x equals e to the y. That is a concept we're going to need to know when it comes time to solve using natural log and e. Also, we actually already mentioned one of these properties of log base b of b is 1. For that same reason, natural log of e is 1. And if you're struggling, why is that true? What is the natural log? Well, it's a log with a base of e with a quantity of e. You see how these are identical? That is why it equals 1. The best news about natural logs is all the properties you had with regular logarithms about the product and the power, they're the same. They're the exact same. So the same skills you're using to solve log equations, you're going to use to solve natural logs. And we're going to show two of those right now. So I have 2 plus e to the 4x equals 5. Get e alone. Get e alone. And again, why are we getting e alone? Because it has the exponent that contains my variable. Same way you would do if it was normal. So I'm going to subtract the 2. I get e to the 4x equals 3. Now again, your variable is in the exponent. So at this point, up till now, we've taken the log of each side. That's not a bad idea, but I have a better idea. We can take the natural log of each side. And here's why I'm going to do that. Two things beautiful are about to happen. If I take the natural log of each side, I'm still technically taking a log of each side with the same base, but a couple things happened here. Where's the 4x go? Out front like you wanted it to. And now it's 4x times the natural log of e equals the natural log of 3. But, lo and behold, what is the natural log of e? It's just 1. So you realize it completely goes away? And now you just have 4x equals natural log of 3. It's very nice. Now, quick calculator tutorial. Again, I'll just be referring to the one that I've used. This is a wonderful one to use to find any kind of logarithm. You'll notice there's an ln button. Where's the camera? There it is. ln, and right above it, if you can see, e to the x, that's the money when it comes to natural logarithms. So from this step, I'm going to divide by 4. So x is just the natural log of 3 divided by 4. So in my calculator, I will hit natural log of 3. Now be very careful with your parentheses. End that parenthesis. End the parenthesis, and then I divide by 4. Bam. You should come up with approximately 0.2747. Pretty basic. It's the same way. Remember how you took the log of both sides. Whenever you have e, you take the natural log of both sides, and it has a much better purpose. All right, let's take a look at another one. All right, natural log of 5x minus 2 natural log of 3. I'm going to use the exact same properties we know from logarithms. That 2 is really an exponent for the 3, which means I really have natural log of 9 here. So I'm going to rewrite it. I'm going to go slowly. We have natural log of 5x minus natural log of 9. All right? Now we're subtracting 2 logs with the same base, which means they can be combined and just divide our quantities. So I get natural log of 5x over 9 equals 1. Okay, now look at what we have. We have a single logarithmic statement. We can't really go any further with logs, so to solve this, we put it into exponential form. What we use here. So this becomes 5x over 9 equals e to the first. Makes sense? It's the same transition. Same transition you do with logs, you are doing with the natural log. And again, it's calculator time. To get rid of a fraction here, I'm going to multiply by 9 over 5. So I know that x is equal to 9/5 e to the first. Okay, calculator time. The e button is above the little natural log. So what I have to do is hit second natural log, and then you'll see the e to the button. Now, I'm going to put to the first, end parenthesis. Now from there, I'm just going to multiply it by 9 and divide it by 5. Enter. You should come up with approximately 4.8929. That's it. If you can solve logarithms, you can solve natural log, and you might even be able to solve it faster because it has some convenient things going on. Quick tutorial on natural logs and how to use them to solve.